Okay, so we got to finish 5.3 and then we got to do a tiny bit of 5.4. You guys have your reference sheets with you. I don't know if I have one on my desk. Yeah. So if you remember, we were using the reciprocal, the quotient, and the Pythagorean identities. And then yesterday I taught you sum and difference identities. On Monday, we're going to learn the double and the half angle identities. And that will be all that we're going to know for the first part of this chapter. Okay. And so when we have our sum and difference, just based on what you're doing, if you're adding or subtracting them, you're going to use that one. So we practiced a bunch using actual numbers and actually solving things out yesterday. Today, what we're going to do is practice verifying. So basically, that's what you just did on your quiz. Now we get to use our sine, our cosine, and tangent, sum, and difference angles as part of our verifying. So like if I look at number 3a, it says sine of x minus pi over 2. That is a difference angle identity. So I'm taking that sine of x minus pi over 2, and I'm going to use my difference of angles. And I'm going to plug that in and expand it out and see if I can get down to cosine of x. Okay. So on your identity sheet, you see that the difference of sine, so sine of a minus b, is sine of a times cosine of b minus cosine of a times sine of b. So we're going to expand out the one that we have, but instead of writing a, we're going to write x, and instead of writing b, we're going to write pi over 2. The only thing I really want to caution you about is be careful, use the right sign and cosines, and follow what your formula sheet says. So I'm just going to go plug and chug. It looks like there's a minus between them. Then I do cosine of x and then sine of pi over 2. All right, now the cool part here is you cannot simplify sine and cosine, so they're going to have to stay, but or sine and cosine of x because they don't have an actual number. But cosine of pi over 2, we know that pi over 2 or 90 has the ordered pair 0, 1. So what's my cosine of that? 0. And then I could also do the same thing for my sine of pi over 2. What's sine of pi over 2? 1. Very good. So once I expanded it out, I now can simplify. And then once I do that, I can multiply accordingly. So sine of x times 0 is just going to be 0. And then cosine times 1 is just cosine. So 0 minus cos x is just negative cos x. Does that equal what we want it to? Yes. Perfect. Smiley face. Okay. We have a very similar one on the next one, but we have to do it twice. So I'm going to be quiet for a second. I want you to expand this out. Do your difference of sine right here. Do your sum of sine right here. And then see if you can combine anything or cancel anything out. One at a time. It gets really kind of long and complicated before we can simplify things out. But as long as you follow your formula accordingly, do you see anything that I can cancel out now? Not all of it.
The cosine x sine x y.
The cosine x sine y, I have a positive and a negative of each of those. But the other ones, sine x cos y and sine x cos y, those are both added. So what is sine x cos y plus sine x cos y? 2 sine x cos y. Is that what I want? Perfect. Nice job. Okay. Now to kind of solidify this in our head, I want to flip over a couple pages into 5.4, but we're going to do some sum and difference formulas. Okay. I want to jump to number 5. So we're gonna try and see how much of A and B on number 5 that we can do, okay? It brings a concept of something that we have looked at before, and now our new thing of the sum and difference formulas, okay? So if I look at this first statement, it says if sine of alpha equals 3/5, and then it says pi over 2 is less than alpha, which is less than pi. That's giving me an angle and its sine, and it's telling me where that angle exists. What quadrant is that angle in? Not 1.
2,
Why?
because the pi.
Because of the,
It's in between 90 and 180.
it's between 90 and 180. Very good, John. So it's in between 90 and 180. So I'm going to draw a triangle in quadrant 2.
I wasn't scared.
I didn't say anything.
This,
The timing is very convenient. I'm gonna now label this with my alpha, and I can do sine, which is what over what in terms of opposite, adjacent, hypotenuse.
over H.
Over H. So opposite over hypotenuse. Can you go about finding that adjacent side?
Yeah.
Yeah, Pythagorean theorem. We've been doing this over and over. You might even know what it is without having to do your Pythagorean theorem out because we've done this enough time.
Why are
And
you
probably,
getting above that?
because I'm gonna need space below.
Oh, okay.
Mhm.
No.
Which is something that you don't know yet, but I'm doing it up there because I'm gonna need this extra space below.
Gotcha.
Now, when I got 4, did you guys get 4 too?
Yeah.
Is it gonna be positive or negative? Ooh,
Negative.
why is it negative?
It's going left.
Because we're going to the left. We're in quadrant 2, we're going to the left, so it's gonna be a -4. Now, we have all the sides labeled. Could you do sine or cosine or tangent or cosecant or secant or cotangent of angle alpha?
Yeah.
Yes, okay? That means now we're gonna look at the second angle. We're gonna look at angle beta. So it tells me cosine of beta is 5 over 13, and then 3 pi over 2 is less than beta, which is less than 2 pi. What quadrant is beta gonna be in?
4,
4. What?
because it's 2 pi, it's all the way 360. And then that's 180.
We're looking at that. Oh, it's in between 3 pi over 2.
Because it's greater than 3 pi over 2.
It's in between. It's somewhere in between 3 pi over 2 and 2 pi, so that means it's somewhere down here.
Will it always be like a 90?
Yes.
180?
Yes. And so I'm gonna draw a triangle down here, and we're gonna do the same thing. We're gonna label our sides opposite, adjacent, hypotenuse. We're gonna label our angle beta. We're gonna label cosine, which is A over H, and then we're gonna find that missing side. And then is this 12 gonna be positive or negative?
Negative.
Negative, because I'm going downward. And now, could you do sine or cosine or tangent or cosecant or secant or cotangent of angle from beta? Yes. We need that because now we're going to do sine of alpha plus beta, and we're going to do tan of alpha minus beta. So we're going to use our sum and difference identities, and on each of them we need sine and cosine for both of them. So that's why we spent all this time drawing those triangles. Okay, so if I look at this one, I've got sine of alpha and beta. So I'm going to use my sum formula for sine. So can you go back? I think we just were using that one a minute ago. The sum of sine of A plus B. We're going to use that, but instead of A, we're going to write alpha. Instead of B, we're going to write beta.
Do we plug in?
We're going to plug those in a second. For right now, just do sine alpha, cos beta, all that fun stuff.
Do you replace it with like over H?
So now, instead of sine of alpha, we're going to go to our alpha and we're going to do our sine.
Would
Which-
it just be 3/5?
3/5. Sorry, my color coordination is a little off. That's my bad. Then for cosine beta, we're going to go to our beta triangle and we're going to do our cosine there. What's that?
-12 over
It's gonna be, cosine is gonna be adjacent over hypotenuse, so it's just gonna be 5/13. And then we'll do cosine of alpha. What's cosine of alpha gonna be?
3/.
That's sine,
Wait, I'm like, I need to write this down.
-4/5.
Okay, yeah.
And then sine of beta is. Sine of beta, sorry, did I say alpha? Sine of beta,
-12/13.
-12/13.
Oh, 1, 3.
And if I did not label opposite adjacent hypotenuse, that's my fault, but don't be afraid to do that. Okay, now you just have a bunch of fractions. This is like algebra 1 stuff. Can you multiply those fractions and then add them together?
Okay.
Sure can. 3 times 5 is 15. 5 times 13 is 65.
I would like.
-4 times -12, 48, and then 5 times 13 is still the same thing, 65. Can you add those two fractions together?
Okay.
With ease, what's that gonna be?
60.
Over 65, perfect.
I did.
That's your final.
That's your final answer.
That was like 16 steps.
Whew. Now, we can do tangent of alpha minus beta really quick because we did all the hard work. We've done all the hard work. We're still gonna use these pictures. We don't need to draw new pictures. We're gonna go look at our equation for tangent minus two angles. So can you go find your tan minus A minus B? I know. Give me a second. So we're gonna do tan of alpha minus beta. I don't know why I have a plus there. And then we're gonna do 1 plus tan of alpha times tan beta. Now, if you remember when we did our unit circle ones, we had to like work our tangent off to the side. We don't have to really work it out because you can just go look at your triangle above. What is my tan of alpha gonna be based on my triangle above?
And
-3/4. So no, not even tan, just -3/4. What's my tan of beta gonna be?
-12/4.
-12/5. And then I plug both of those in everywhere I see tan alpha and tan beta. Now, we'll save the simplifying fractions for next class, which isn't until Monday, but I wanted to kind of set that up for us because it's gonna be easier to catch up here. Okay? We finished 5.3. That homework is due Monday. That homework's due next class, and then we'll finish 5.4 next class. Okay?